What's it like inside the brain of a mathematician? I like to share stories like this with my students to show them what I do when I read math and to show them that it's okay to have questions, to struggle, to miss things. So I was reading this paper last night by Keith Conrad. It's an expository paper about a really cool proof of the fundamental theorem of algebra. Now, we're not going to get into the details because it's a very technical proof, but it says that if you have any polynomial with complex coefficients, unless it's a constant polynomial, it's guaranteed to be equal to 0 at least one point. So I was reading the proof. There are lots of funny jokes, like there's a lemma and the author says, I know of no worthwhile applications of this lemma other than basically exactly what we're doing here. But when I was reading that lemma, when my brain got to not divisible by m, I stopped and said, wait a minute, what's m? I'm missing something. And I went back, and sure enough, the author defined it just one line before. I was just reading too quickly. So I slowed down, I checked everything, I was good. The math kept mathing. I had to check all sorts of little minor things like this, and I was understanding things pretty well. And then we get to the proof of the main theorem. So it starts down here, and it's an induction proof. And so we start with the base case, which is basically where you have an odd degree polynomial. Now, the base case actually takes a long time to prove, and the author even points out, look, the base case of a proof by induction is not always trivial. There's actually a lot of complicated stuff that's going on here. But as I was reading and I was understanding the statements, in the back of my mind I was thinking, wait a minute, why isn't this base case trivial? Isn't it true that any odd degree polynomial will have to cross the x-axis somewhere? Isn't that basically the intermediate value theorem? And I'm thinking this, and I'm thinking, wait, Keith Conrad's really smart, an excellent writer. He wouldn't have missed that. What am I missing? And so I'm still kind of reading, and I actually stopped and really thought about it. And then I got it. I said, oh, right. That would be if you had real coefficients. If you have complex coefficients, then that picture, that intuition is just not even true. You need some argument like this. And so I kept reading the proof. Everything made sense. I was very happy with the proof at the end. And then the wonderful thing that this author does is after the proof, it says, well, what parts of that proof would work for different things other than the complex numbers? And he points out that if we were using the real numbers, the base case would be trivial. And then he says exactly the thought process that I was having. Now, I know some people don't like the word trivial, but it actually was really helpful for me as a reader here because it told me that question I had earlier was exactly right, but the important distinction wasn't the intermediate value stuff, but it was the fact that I was working with the complex numbers rather than just the real numbers. If you like this, I can post more videos where I read math papers and you can see what's inside of my brain.